Let's see the one more example for the job sequencing with deadline. Right, please take care. One problem I done, so this is the second problem. See the answer. N is equal to 7, means 7 jobs. Jobs, profit, deadlines. J1, J2, J3, J4, J5, J6, J7, right, 7 jobs. Profits, let's give some random numbers, 80, 20, 90, 50, 30, 60, 85, some numbers I have to give. Deadlines, let's see this one, 6, 3, 4, 3, 1, 2. Some numbers I have to give, I am given. See this. So this problem, how to solve, I am starting. You know very well. So what is the first step? What is the answer for this one? Can you say first step? To this problem, how will you solve? First step. See the first step. Very simple. Whatever you know, that only. See the first step. What is the maximum? How many jobs total? 7. That is okay. 7 jobs are there. It doesn't mean that I will do every job. It doesn't mean that. Can you help me now? Maximum. See the deadlines once. What is the maximum deadline? 6. Maximum deadline 6 means maximum I can complete 6 jobs. Not 6 jobs. Maximum deadline 6 means, right? Maximum I can complete 6 jobs. Maximum. Maybe sometimes less also. You will see how it is. Number of jobs are 7, but I cannot complete 7. How many I can complete? It is based on maximum deadline. Maximum deadline 6 means maximum I can complete 6 jobs. Let's see. Maximum. Sometimes maybe less than 6 also. How it is? Let's check. 1, 2, 3, 4, 5, 6. Maximum 6 jobs I can complete. Okay, I took already. Next one, can you help me now? If you start from this side, what is the answer? All will fight. Can you help me now? Who can fight for first month? Everyone know. Deadline 6 means what? 1, 2, 3, 4, 5, 6. What is the meaning? Deadline 6 means 1 to 6, 1 to 6 anywhere he can done. Deadline 6 means he is having this one. More deadline, more flexibility. Can you help me now? Who can be done in first month? Who can be done in first month? Those people who are having deadline 1 or more than 1 also can be done. Deadline 2 can be done here also. Deadline 5 can be done here also. Please be careful. Who can be done in first month? Those people who are having deadline 1 or more than 1. Please be careful. Can you help me? Who can be done in fourth month? Those people who are having deadline 4 or more than 4. 5 also can be done here. But one thing, in the fourth month, those people who are having deadline 4 or more than 4 can be done. But one thing, deadline 3 cannot be done here. Deadline 3 can wait until here. Right? Last one I want to ask you. Who can be done in the 6th month? What is the answer? Those people who are having deadline 6 or more than 6. Deadline 7 also can be done here. But deadline 5 cannot be done. Right? Please be careful. So now I am starting, I think everything fine. If I start from this side, all people fighting here, lot of competition. Let me start from this side. I am starting from this side. Can you help me now? Who can fight for the 6th month? Those people who are having deadline 6 or more than 6. Some people are asking, sir, how to find out? Nothing there. Just come here and ask. Ask him, are you 6 or more than 6? Yes, he is fighting. Next one, you want any fighter or in all the fighting people best one? All fighting people best one. Let me check. Who can fight for the 6th month? Those people who are having deadline 6 or more than 6. I am asking, are you 6 or more than 6? Yes. But let's see, maybe some other competitor, I have to take best one. So, are you 6 or more than 6? No. Just to do one scan like this, linear search, asking everyone. I asked everyone saying no. But one person only said yes. Only one person said yes. Even though it is the worst one, I have to take. Even though it is a 3, I will take. Because only one person. So, only one person is there, even the worst I can take. It is the worst one, best one, doesn't matter. Only one is there. So, to this place, only one person fighting, whatever it is, I will take. Who is that? J1. J1 will be taken. But one thing, to this slot, you are asking every person. Can you say how much time? Order of n, linear search. Worst case, asking everyone. Some people are asking starting itself matching there. Why are you asking all? I don't want any matching here. I want best matching. I asked everyone, only one person satisfied, I will take him. Right? Instead of keeping the gap, whoever is matching, keep here. Suppose isn't that he is also matching, he is also matching, he is also matching. I think best one is 90, I will take 90. But he is not matching. Right? Linear search I done, worst case order of n. Next one, can you help you know? Who is fighting for 5th month? Those people who are having deadline 5 or more than 5. So let me ask, who can fight for the 5th month? It is already over. We are already stored there. Who can fight for 5th month? Those people who are having deadline 5 or more than 5. Let me ask everyone. Is it 5? This is already over. That is the reason. Are you 5 or more than 5? No. 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 I asked everyone. No one is matching. If no one is matching, keep the gap. If no one is matching, keep the gap. Some people are asking, sir, how can I keep the gap? I will keep the J3 deadline 4. You cannot do in 5th month. J6 deadline is 1. You cannot do in 5th month. Please be careful. So, no one, I think I asked everyone, no one fighting, just leave it. That is the reason I said to you, see this one, maximum deadline 6 doesn't mean that I will complete 6 jobs. Maximum deadline 6 doesn't mean that I will complete 6 jobs. I may complete 6 jobs. I may. Right, in the previous problem, maximum deadline 2, I completed 2. In this problem, maximum deadline 6. I may complete 6, I may complete less. But one thing more I cannot complete. 6 or less than 6, I will complete. See, here gap is there because no one is there. What can I do? Next one. Right? Who is fighting for 4th month? Those people who are having deadline 4 or more than 4. Let me ask. 4 or more than 4? No. Yes. It is also yes. I think 2 people fighting. If 2 people fighting, who is the best person? I think J3. So, I will take J3. Some people are asking, sir, why don't you take J4? J4 I cannot take here. His deadline is 5, but this is only 4. That is the reason. So, 4th month purpose, 2 people fighting, winner is J3. That's okay. I think linear search you done. Worst case n time. Some people are asking, sir, little bit decreasing. If you want, you can take n minus 1. That is also same story. Can you help me? 3rd month purpose, who is fighting? Let's check 3 or more than 3. Yes, he is fighting. He is also fighting. He is also fighting. I think 3 or more than 3. I think 3 people fighting. 20, 50, 30. Which is the better? 50. I think J4. Next one. This is also order of n. Next one. Can you help me? Who is fighting for 2nd slot? Those people who are having deadline 2 or more than 2. It is fighting. It is also fighting. It is also fighting. So how many people are fighting? Right? 1, 2, 3. 3 people are fighting. Best one, I think J7. This is also order of n. Next one. Can you help me? Who is fighting for 1st month? Let me check. 1 or more than 1. This is fighting. This is also fighting. This is also fighting. Can you say best one? Right? I think 3 people are fighting. Best one, I think J6. Some people are asking, see this one. Some people are asking, sir, even though J6 having deadline 1, still he came. Even though J6 having deadline 1, still he came. What is the reason? He is having best value. Right, everywhere best choice we are taking. Right, can you help me now? If you start from right hand side, one advantage is going to be less comparison. One more advantage is going to be less deadline people you are giving chance at the starting itself. More deadline people will fight at the last places, right? Less deadline people will get the opportunity at the starting. If I start from this side, everyone will fight here. Less deadline people, more deadline people, everyone will fight here. Maybe more deadline person may be winner here. But one thing, more deadline person can go anywhere, right? What you want to do at the starting only. What is the best idea? More deadline people can be done at the last. So if you do from this side, one advantage, less comparison, one more advantage, more deadline people will go to last places so that less deadline people will get opportunity at the starting. That is the reason. 2 advantages. Right? Anyhow, just to take the maximum deadline, that much size array you take, start from right hand side, just ask everyone using linear search. So, like that you can do. I hope everyone fine. Some people are asking, sir, why don't you do binary search? See, no sorting there. Sorting not there. How can you do binary search? So that is the reason for this. So can you help me? Final answer. Final answer I want to ask. What is the profit you got? To this problem, finally, what is the profit you got? Whichever you completed. Can you say? Whichever you completed. What is the lastly came? J6 came. J6 also I am cancelling. Whichever is completed, add all of them. Add all of them. Can you say who is completed? J6. How much? J6 is going to be 60 plus J7. How much? J7 is going to be 85. Next. J4, what is the J4? 50. Next one, right, what is the J3? 90. Next one, what is the J1? 80, right? Add all these things, that is the profit. Next one, can you help me? Some people are asking, what is the optimal solution sequence? What is the optimal solution sequence? Same thing, just write as it is. What is the answer? First to J6, next to J7, next to J4, next to J3, next to J1. And one more interesting answer. See there one more interesting answer. Can you help me now? Can you help me now? Right? So, 6th month purpose, how many people are fighting? Listen this line also, small line, this also listen. Can you help me now? 6th month purpose, how many people are fighting? 6th month purpose, only one person is fighting. That is the reason I stored him. Can you help me now? 6th month purpose, how many people are fighting? Only one person. Who is that? J1. J1 I stored. Some people are asking one interesting line. 6th month purpose, right? Only J1 fighting. That is the reason I stored the J1. It's okay. But one thing, if J1 deadline 6 means, what is the meaning? If J1 deadline 6 means 1 to 6 he can be done anywhere. If J1 deadline is 6 means 1 to 6 he can be done anywhere, but I done in the 6th place so that less deadline people will get opportunity at the starting. I thought that someone can utilize this, but no one is utilizing. So then J1 will think that, right, I can be done anywhere. I thought someone can utilize this, no one is utilizing, right? J1 may shift here. Please be careful. That is also okay. J1 is thinking that my deadline is 6, so I can go 1 to 6 anywhere, but I will go to 6th place only. The reason is less deadline people can use before me, but he got to know that no one is using 5th slot, so he can shift from 6th place to 5th. Chance is there, see, no one using, he can go there also, you can shift. But one thing is true, gap is there at the 5th place, gap is there at the 6th place, anyhow it's okay. Finally, sequence, if you see the sequence, what is the answer? First to J6, next to J7, next to J4, next to J3, yes, next to J1, right? If you want, you can keep gap followed by J1 or J1 followed by gap. Sequence is this. It is the profit. Just add them, whatever will come, will come. Next one. What is the penalty? Whatever you left out. Whatever you left out, those values you write, that is called penalty. Can you say what is left out? Is J1 is left out? No. J2, yes. J2 left out, J3 there, J4 there, J5, yes, J6 there, J7, yes, right? Can you help me? How many jobs total? Total jobs how many? Total jobs are, I think, 7 jobs. In those 7 jobs, right, I think 5 jobs you done, remaining is 2. I think 2 things came. What are the weight of those? What are the profit of those? J2 profit? J2 profit is 20. What is J5 profit? J5, 30. Right, this is going to be penalty, right? Please be careful. Right, I am thinking that you are fine, really fine here. It is a J1. If you want, you can shift also, right? It is a J1. Fine, this problem is over. This is the way of solving. Let's take one more example. Example 3. See, in this one, you will see one more step extra. I want to say starting itself, you may be disturbed. That is the reason I didn't mention, right? Let's see one more example. Write down. N is equal to 9, right? In one of your previous paper, this is given. For 4 marks, this question is given. Example, one more example, N is equal to 9. Jobs, profit, deadline. Right, 9 jobs. Right, let's give them some numbers. 100, 50, 80, 150, next one 30, 90, 40, 60, 80. You may say that same number. Maybe see, whenever these two are fighting, take any one. Because I want maximum profit. Both are giving same. You take any one, no problem. Let me give deadlines also. 4, 3, 5, 7, 5, 3, 2, 5, 4. Some numbers I have to give, I am giving. Right? This is the next problem. Please be careful. This problem also, if you can solve job sequencing with deadline, you completed successfully. At least be comfortable here. One more new step is there. If you don't do that new step also, it's okay. But new step will save the time. Right? See this one. I think 3 problems I given. If from now onwards, if you do any problem of job sequencing with deadline, the new step what I am doing, right? Until now, because of small problems, size is very less. That is the reason that step not needed. Right? Now this step also if you do, right, it will save a lot of time also. It will save a lot of time. So, some people are asking, sir, how? I will explain. Right? One new step is there. Let's do that also. Let's check. See the first step now. Make sure that everyone listen. See the first step. Job sequencing with deadline, whatever you know until now. That is correct. Fine. But one more new step there. Let me do that also. See this one. First one. Arrange all jobs in decreasing order of profits. That is the first step. Some people are asking, sir, what is the need of doing like this one? If you arrange all the jobs in the decreasing order of profits, who will be there in first place? Maximum profit. Next place, next maximum. Arrange all jobs in decreasing order of profits. That is the first thing what you have to do, so that maximum profit person will be there in first place. Now here, if you see directly, what is the answer? Maximum profit person can be there anywhere. Maybe here, maybe there. So if I see directly, he can be anywhere. But after this step, if you see, maximum profit person will be there in first place. Right? Let's see this one. Arrange all jobs in decreasing order of profits. Let me arrange. Can you help me now? Who is the maximum profit? I think J4. J4, 157. Next. 150 over. Next. I think J1, 104. That is also okay. Next. J6, 93. That is also okay. Next. J9, 80 and 4. That is also fine. I think 80 also over. Next, I think 2 80s are there. You can write in any order. J3 also you can write. J3, 85. That is also 2 80s, you take any one. No objection. 80 is also over. Next, in the available one, better one, I think 60. J8, 65. Next, in the available one, 50, 30, 40. Best one, 50. J2, 53. Next, 30 and 40 there. So what is the answer? J7, 40 and 2. This is also fine. Next one, J5, 30 and 5. This is also completed. So can you see how many jobs total? I think 4, 1. I think totally 9. 4, 1. I think total 9 people. So you arranged all the jobs in the decreasing order of profits. Who is there in first place? Maximum profit. Next place, next maximum profit. Next place, next maximum. I know very well, right? Where is the maximum profits? Where is the minimum profits? I know very well after this step. Can you help me know? This step is taken how much time? You know very well. Sorting. Using merge sort you do. How much time? N log in every case. This step is taken N log in every case. See the second step. See the second step now. See the second step, can you help me now? From the second step onwards, as usual, whatever you know about this algorithm, same thing. Instead of doing on the random array, do on the sorted array. Right? Previously, we were doing directly maximum deadline and all directly on the random array. Now on the sorted array, you do that. So can you help me now? Just scan the array and check what is the deadline maximum? 7. So 7 slots you take. 1, 2, 3, 4, 5, 6, 7. So take one array with 7 slots. Yes, I took. Next one. Say previously, whatever you done, previous two problems, whatever you done, same thing you do. The only thing is on the sorted array you do. I'm doing now. I'm doing. Can you help me now? Right? Can you help me now? Who is fighting for 7th month? You know. Who can fight for 7th month? Those people who are having deadline 7 or more than 7. See the answer. Those people who can fight for the 7th month is who are having deadline 7 or more than 7. Like previous problem, you check. Let me ask. Are you 7 or more than 7? See this one. Are you 7 or more than 7? He said yes. Listen. Are you, I am asking this person. Are you 7 or more than 7? He said yes. When he say yes, can I go further or can I stop? I can stop. Previously, I have to go further. What is the reason? This may be better person, this may not be better. He is matching, it's okay. But previously, because of not sorted, he may be better, he may not be better. Now he is better because of I sorted in the decreasing order. He is the maximum profit. If I go further, even though one more 7 is here, but it cannot be 150. It cannot be more than 150 because the decreasing order. The advantage after sorting is going to be ask first person, are you competitor for this slot? Yes. If it is yes, don't go further. What is the reason? Already best person you got, who you want to go further. So that is the advantage after sorting. So J4. Can you help me now? Previously, what should I do? Because of not sorted previously, even though he is saying yes, I have to ask everyone. So previously, every time order of n. But here, worst case order of n. Suppose if the matching not there, then I will ask next one, next one, next one, next one, next one. So in this approach after sorting, worst case is n, linear search. But here, right, best case 1. Previously, worst case also n, best case also 1, n. But here, worst case is going to be n, best case 1. See, best case 1 came. In the previous one, before sorting, you cannot stop here. You have to ask everyone. If you want, you can check the previous problem. Every slot order of n. Every slot order of n, every case, best case also, worst case also, average case. But here, worst case is, and I am asking this person, are you matching this one? Yes, then stop. Best case 1. Worst case, I may ask everyone. Right? Fine. So, order of 1, whatever it may be. Can we come here now? So, this is going to be J4. Can you help me? Who is fighting for 6th slot? I have to ask like this. Are you 6 or more than 6? No. No. See, no one matching. That is the reason. Worst case n. Please be careful. Previously, every case n, now worst case only n. No one fighting, that's okay. Can you help me now? Who is fighting for 5th month? Let me ask. I am asking everyone, he is matching. See this one. He is matching. This person is matching, it's okay. Whenever first person is matching, why should I go further? If you go further, profit will decrease. So, wherever first matching, stop there. So, what is the answer? J3. Next, right? Worst case, order of n. Worst case, right? Best case may be 1. Next one. Can you help me now? Who is fighting for 4th month? Who is fighting for 4th month? Same. 4 or more than 4. Ask everyone. I think here itself matching. What is the number? J1. Right? Best case is 1. Worst case n. Previously every case n. Next one. Who is fighting for 3rd month? 3 or more than 3. Wherever you see first matching, stop. J6. Right? Best case 1. Worst case n. That's okay. Next one. Who is fighting for 2nd slot? 2 or more than 2. I think this one. J9. So that is the advantage if you sort. See, most of the people are matching it. So it is very rare incident going to extreme corner. But in the previous one, before sorting, every time I have to go, starting to ending. But now, very rare incident, I will go to last place. Can you help me now? Who is fighting for 1st month? 1 or more than 1. 1 or more than 1. I think this. J8. So like this. First to sort, afterwards, as usual, same procedure. Right? Now can you help me now? What is the maximum profit? What is the profit you got maximum? Add all of them. What is the J8 value? J8 value 60. What is the J9 value? J9 value 80. What is the J6 value? 90. What is the J1 value? 100. What is the J3 value? 80. What is the J4 value? J4 somewhere. J4 starting 150. So if you add all of them, maximum profit will come. Next one. What is the sequence? You will ask this also. What is the sequence you followed? Same thing you write. What is the answer? J8, J9, J6, J1, J3 and J4. Some people are asking, what about this gap? If you want, you can keep gap here. But one thing, what is the J4 deadline? 7. What is the meaning? 1 to 7 anywhere can be done. He thought that someone will utilize. No one utilizing. He may shift here. J4, if you want, you can write. Next one. What jobs are left out? That is called penalty. Can you help me know what is the penalty? What jobs are left out? J1 is there. J2 not there, yes, J3 there, J4, yes, J5, no, next one J6, yes, J7, no, J8, yes, J9, yes, I think 3 people. 3 people. If you want, you can check. Total people how many? 9. Out of 9 people, how many people are completed here? 6, remaining 3. What is the J2 value? Check once. J2 value 50. J5 value 30. J7 value 40. If you add them, you will get a penalty. That is also okay. Now I am thinking you are really comfortable. Can you say decreasing order will take how much time? N log n every case. Can you help? This particular second step will take how much time? Every slot worst case n, like that n time approximately. So what is the answer? N square. Which is going to be worst case. Can you say best case how much? Every slot is 1, right? Every slot is 1, like that n time. Every slot is 1, like that n time, then n will come. Then n plus n log n, n log n. Now let me write now. Time complexity of this algorithm, what is the answer? N log n plus n square, worst case. What is the best case? N log n plus n log n. N log n, best case. Right, like this. Please be careful. No one will ask you time complexity also, right? This is the way of finding time complexity. Mostly numerical problems you can expect. Can you help? 2, 3 problems I done. First problem, second problem I didn't done sorting. If you do sorting is not ascending order, descending order. Descending order keep so that maximum profit person in the first place only. So when you start searching, starting maybe you will get, then no need to go further. Right? If you don't sort, every time you have to go starting to ending, then every time n, like that n time n square. So every case n square time complexity. Now here worst case only n square. Best case n log n. But if you don't do sorting, every time n square. Right? Fine. Mostly numerical problem. Right? Otherwise time complexity may ask like this is the time complexity. Don't by heart, meaningfully you study. In algorithm subject, everywhere we will see time complexity only. Everywhere you see space complexity and all. Mostly space may not be there. Right? Time complexity mostly will come. In every problem, time complexity like this one. Meaningfully you study. No need to by heart. Even I don't know what is the time complexity of this algorithm, right, until I explain to you, right? So while explaining, okay, I will get, this is the first step, this is the second step. If someone suddenly will ask me time complexity, I may not know. If I know procedure, I can analyze, okay, first sorting required n log n. Afterwards, for every slot, I have to do linear search n, like that approximately n time, right? So n square. Worst case is n square, best case is going to be n log n. Average may be in between, right? No one will ask you average also. That is the reason I didn't return. Fine, I am thinking you are okay. So this is the second application of, right? So greedy technique. So time complexity also I explained, 3 numerical examples I explained. From now onwards, this algorithm you follow. Any problem given for job sequencing with deadline, first to sort, right, in the decreasing order of profits. Then afterwards do this step. Every slot. Start from right hand side, keep on asking who is matching. Right, that is the second application. Go to the third application. Let's see the next application of greedy technique, Huffman coding. Next application of greedy technique is Huffman coding. Let me start. Right, it's a nice application, right? So in gate examination, either first one will be given or second one will be given or this one will be given, right? Please listen this also. One problem I will do, one problem you do, that is enough. See this one. One problem, right, I will explain clearly all my required things. Second problem, for your convenience, I will do one more, right? I am starting, see this one, Huffman coding, carefully listen. Huffman coding purpose is going to be, it is a data encoding technique. Data encoding technique. If you want to encode the data, it is one of the idea. Data encoding technique. One more idea is going to be, what is the one more purpose? Data compression technique also. Data compression technique. It is a data encoding technique and it is a data compression technique also. 2 ways it is useful. Some people are asking, what is the meaning of data encoding technique? Suppose in that I have some data, assume I don't send as it is. I will send in some other way. That is called data encoding technique. Suppose I have assumed that A. I have assumed that small a, which will goes to 97, something like that. Small a, 97 and all. Right? I will send small a in terms of maybe 97. in terms of bits. Some other format I will send. I may not send as it is, I may send some other way. Right? That is the meaning of encoding technique. It is the data compression technique also. What is the meaning? You don't send blindly data. It will compress the data, it will send. It will compress and it will send. How it is, you will see within few minutes. If someone asks you, say something about Huffman coding, what will you say? It is the data encoding technique, it is the data compression technique. If they ask you how, right, I will explain one problem. See the problem. One problem I am explaining. One example. See one example now. So assume that there is some message M. Careful listen. There is some message M. There is one message M which contain 100 characters. I have some message M which contain 100 characters. Which contain 100 characters. I am repeating once again. I have one message, right? That message contain 100 characters. That message contain 100 characters. Message M is contain 100 characters. Please be careful. Next one, some people are asking, sir, message M contain 100 characters, you are saying it's okay, but who are those inside? Let me check, right? Message M contain 100 characters, it's okay, but inside who is there is, right? Inside only 6 people are there. Total number of characters are 100 characters, but distinct characters are 6 only, A, B, C, D, E, F, only 6 characters. Total message, this message name is M, which contain 100 characters. But distinct characters are 6 only. Who are those? A, B, C, D, E, F. What is the meaning of? What is the meaning of? Distinct people 6, but total is 100. What is the meaning? Some characters are repeating. Some characters are repeating. That is the meaning of this one. Total is 100, but 6 distinct people. Means some people are repeating. Let me write here. Let me write roughly. Out of 100 times, 45 times this only repeating. Out of 100 times, 45 times this only. 20 times is this. 20 times is this one. Next one is going to be, let me check here, right? So here 30 times. How much it is? If I write 30, 45 plus 30, 75 plus 20. What is the answer? 45 plus 30, 75 plus 20, which will become 95. I think these people I have to arrange. Right? Let me check. Let me arrange here. Let me arrange. See this one. It is 1. It is 3. It is 1, some numbers, what is there in that? So 45 plus 30, 75 plus 20, 95 plus 5, which will goes to 100. Some way I distributed, nothing there. So message M contain 100 characters total, distinct characters are 6 only, means some characters are repeating. Who are those? Some characters are repeating. Who are those? A repeating 45 times, C repeating 30 times, E repeating 20 times, B repeating only 3 times, D repeating only 1 time, F repeating only 1 time, right, like this. Now some people are asking, so that's okay, right, some message is there, everything is okay. Now what is the goal? Our goal is we want to transfer this message M from sender to receiver. We want to transfer this message from sender to receiver. How it will be done? How it will be done? We will see now. We want to transfer this message from sender to receiver. How it will be done? What exactly happening? I will explain. See this one. To transfer this message from sender to receiver, let me give first one initial idea, right? Let me give some initial idea. Afterwards, we will go to the Huffman coding. See this one. See, using ASCII representation, I am transferring. Using ASCII representation, I am transferring. You know very well. Whenever this data is going, right, from sender to receiver through, right, through electronic media, you know very well. This media will understand only zeros and ones only. So what is the meaning? A cannot go as A, right? It will go in terms of zeros and ones. B also cannot go as B. It will go in terms of zeros and ones. Please be careful. So I am representing all of them. So everything will go through transmission media in terms of zeros and ones. I am showing all of them. I am encoding all of them into, right, ASCII format. Can you help me one small line? ASCII character. How many bits required to represent? I think character, I think which will goes to 1 byte approximately, right? I think 8 bits required to represent A, 97, right? ASCII character representation. What is the answer? 97. I think almost like 8 bits required. Character 1 byte. So assume that using 8 bits you are representing. Now see what happened. Can you help me? A repeating how many times? 45 times. Every time 8 bits required. Can you say B repeating how many times? 3 times. Every time 8 bits. C repeating how many times? 30, right? Every time 8 bits. D repeating how many times? 1, every time 8 bits. Can you see E repeating how many times? 20, every time 8 bits. F repeating how many time? One time. Every time 8 bits. Can you help me? Total how many bits you have to transfer for 100 characters? Right? How many you have to transfer? 100 into 8. Every one. What is the answer? 800. 800 bits you have to transfer. Every one is 8. Right? For 100 characters are there. Every one 8 bits you are representing. So 100 characters purpose 800 bits you are transferring. What about one character? What about one character? What is the answer? 800 by 100 bits per character, which will goes to, this is called as average. One character, how many bits you are transferring? This will goes to 8 bits per char. This is called as average, everything fine. Everyone know this. So I want to transfer my message M from sender to receiver, but transmission media need everything in terms of zeros and ones. So in ASCII format I am representing. To represent ASCII character 8 bits required, A 45 times, every time 8 bits. Like that all the people I done. So finally 100 characters 800 bits I have to transfer. So one character 8 bits per char. This is called as average. I am thinking that everything is fine. Now see the interesting answer. To transfer 100 people, right, 100 character, 800 bits you are transferring, on an average 8 bits per character, that's okay. Now the question is going to be, see this one, now the question is going to be, can you compress? Can you compress? That is the debate. Actually, this is the place where our story will start. Can you compress? Everyone know. Huffman coding is data compression technique. Can you compress? Yes, I will compress now using, I will compress this data now. Now see this one, how many bits you are transferring for 100 character? 800 bits. Now I will compress using, right, Huffman coding. If you want, you can check. Directly this one. This is the place Huffman coding will come. Next problem onward. Don't do previous things. Do only Huffman coding, because our goal is Huffman coding only. Only to show to you what actual meaning of Huffman coding and all. I done starting step also. Can you compress? Right? Huffman coding is data compression technique. Without Huffman coding, if you do 800 bits you have to transfer for 100 character. With Huffman coding, very less you will transfer. Some people are asking how I will do now. So please be careful from now onwards. Huffman coding I am doing. See this. See the answer. I am starting the Huffman coding. From now on, this is the only Huffman coding, not previous. Next problem onward, do this area only. Do this part only. I am starting. See the answer. I am starting now. Please see all the total 6 different people. Please see that. A, B, C, D, E, F. See the Huffman coding first step. A, B, C, D, E, F. Right? See all the 6 people. Let me ask one small line. Out of those 6 people, who are the 2 minimums? 6 people are there, it's okay. Out of those 6 people, who are the 2 minimums? 2 minimums. Who are the 2 minimum? Out of those 6 people, who are the 2 minimums? I think what is the answer? F and D. D and F, right? One thing, too small you have to take. According to Huffman coding algorithm, take 2 minimum people. I think take 2 minimum people, it's okay. But left side is smaller, right side is bigger. Who are the 2 minimum? Because of both are equal, you can take FD also, DF also. But Huffman coding saying that left smaller, right bigger. 2 minimums you take, left smaller, right bigger. But because of both are equal, you can take any order. Let me write now. D I will take first, F I will take next. Because of both equal, any order you can take. Take 2 minimums, yes I took. Right? Let me delete this. I took both. When you took already, right? When you took already, you can cancel. Take 2 minimums, first minimum, next minimum. Okay, you deleted. Now add these two. Add these two. Right? 1 plus 1. What is the answer? 2. Take 2 minimum and cancel there. Right? Just add both of them. This is called combine, something like that. Add both of them. You got 2. These 2 once again insert inside. So 2 people out, 1 person came. Total how many? Previously 6 people are there total. 2 people out means 4 there. Lastly 1 person came in. Totally 5. What is the meaning? 2 go, 1 will come. What is the meaning? Overall 1 only going. So 6 people, 2 going means 4 there. Afterwards result came back. What is the meaning? 1 came. 2 going, 1 coming means 1 only going. So 5 people are there. Same story continue further. Once again start. Can you say? In the available people, including new one also. In the available people, including new one. Can you say who are the 2 minimums? Can you say who are available now? Can you read 45, 3, 30, 20 and including 2 also. In the available people, who are 2 minimums? Who are those? I think 2 will come. Next 2 minimums. 2 and B also. B 3, right? This 2 also. Available people are these. This one also, this one also, this one also, this one also, this one also. 5 people. Among all, right? 2 minimums. It is also first minimum, it is the next minimum. First minimum on the left. So 2k, I think it is already there. See this one. He went. If at all he is minimum, he will come back. Please be careful. This 2 I kept there because of his minimum in the next round he came back. So can you help in the next minimum? 2, right? Okay, he came back. Next, I think B 3. So left one is going to be smaller, right one is going to be bigger. B 3. Add them. I think 2 people came, delete. Now add both of them. Then what is the answer? 2n, right? This is 2, this is 3. What is the answer? 5. This 5 is came inside. Now can you help in how many people inside now? 1, 2, 3, 4. 2 times you done, see this one. This is 1 merging, this is 1 more. 2 times you done, 2 people out. So out of 6 people, only 4 left. Can you read 45, 30, 25? Once again take 2 minimum. Who are those? Once again take 2 minimums. Who are those? 5 and 20. 5 and 20. I think 5 came. I think already there. Same person came back. He will go. If at all he is smaller, he will come back. Please be careful. 5 next to 20. So 5 left to, right? E 20 right. Which will goes to 25. Let me delete both. 20 is out. 5 also. Totally 25 came. Now 3 people are there. In the available 3 people, 2 best people, who are those? 25, 30. I think 25 there, 30. 30, what is the name? C. Add them. How much? 55. So let me delete both. 55. Next one. In the available people, take 2 minimums. Who are those? 45 and 55. 55 already there. 45 left. A 45. Add them. How much? 100. Lastly 100. Total is 100. So 100 will come. So let me delete this. So Huffman coding will say that every time take 2 minimum, 2 minimum, 2 minimum. 2 minimum you take. Result whatever came, you keep inside. Again next 2 minimums you take. Right? Suppose, so these 2 I will keep. If at all in the next round he is the next minimum, he only will come back. If you don't come back, someone else, it's okay. We want to take always 2 minimum in the available people. Not from here. In that particular round, whoever is the next 2 minimums, you have to take. This is called as, listen, this is called as, right? Two-way Huffman encoded tree. Two-way Huffman encoded tree. Two-way Huffman encoded tree. This is called two-way Huffman encoded. First create the tree. Yes, I created. See, assume that you are comfortable until now. See this one. How can you compress further? How can you see this one? This is the message. What 100 people 800 bits I am sending. Can you compress? Yes, I tried. What is the name? Huffman. This is called as Huffman coding. What is the logic? Every time take 2 minimum, 2 minimum, 2 minimum. Like that create two-way Huffman encoded tree. Some people are asking, sir, why you said two-way? Are you taking 2 minimum or 3 minimum? 2 minimum. If you take 3 minimum, that is going to be 3-way Huffman encoded tree. You may give in the exam 3-way maybe. Right? It is a 2-way. Take every time 2 people, 2 people, 2 people like that. Okay. After getting the 2-way Huffman encoded tree, see this also. Right? See this one also. Listen. After getting this tree, what will you do is, in this tree, every left edge labeled by 0, right edge labeled by 1. Give left 0, right 1. Left 0, right 1. Give the labels like that. After completion of the tree, right, in this tree, left edge labeled by 0, right edge labeled by 1 you give. Right? Fine. So, now see the next story. See the next story now. So, I have given, that is also okay. Now, see what will you do is, careful listen, after giving the labels, left 0, right 1. Now what will you do is, see this one, see correctly this line. In this diagram you observe, can you help me know where is A in this diagram? In this diagram where is A? A is here. Can you help me know? From root, carefully listen, from root to reach that particular A, what labels you have to read? What label? 0. So A Huffman code is 0. From the root to reach A, what labels you have to read? 0. So A Huffman code is 0. Can you help me now? What is the B Huffman code? Start from here, start from root. Where is the B? Find out here. B is here. Starting from root to reach B, what code, what labels you have to read? 1 0 0 1. 1 0 0 1. Right? That is the B code. Let's go to the C now. Start from root. Where is the C here? from the root to reach C, what labels? 1, 1. D, from the root to reach D, this one. From the root to reach D, what labels you have to read? 1 followed by 4 zeros. Next one, E, from the root to reach E, what labels? 1, 0, 1. Right? A, B, C, D, E, F. From the F to reach E, 1, 0, 0, 1. 1, 0, 0, 1. From the root to reach F, what label? 1, 0, 0, 1. I think A, B, C, D, E, F. What is the D? 1 followed by 4, right? 1 followed by how many zeros? 4 zeros. What is the E? 1, 0, 1. What is the C? 1, 1. What is the F? I think all the things are covered. I hope everyone fine. This is, see this one. This is. Listen everyone now. This is, right? For the Huffman coding, this is question number 1. What you can expect? What is the question number 1? Huffman code for every character. Huffman code for every character. For every character. Huffman code for every character you will ask in the exam. This is the answer what you have to give. Right? Please be careful. Next one. See the next one now. Huffman code for every character he will ask you, just identify, just to draw the tree first, right? From the root to reach that particular label, right? To reach, see this one, from the root to reach that particular label, right? What edges you have to read, just keep those. This is called Huffman code for every character. See the question number 2, what they will ask. See the question number 2. Total number of, see everyone, total bits how many you have to transfer. Total bits, let's check. Total bits how many? Can you help me now? What is the A frequency? See the interesting answer. Total bits how many you have to transfer? I am calculating. Can you help me now? What is the A frequency? 45. If you want, you can see here also A45. That is also okay. A frequency is going to be 45. But right, to represent A in this representation, 1 bit only you are using, that is 0. Bit is 0, that is okay. But number of bits are 1 bit. To represent A, I am using 1 bit only, that is 0, fine. So 1 bit only you are using to represent A. So A is repeating 45 times, every time 1 bit only I will use. But in this representation ASCII, to represent A, 8 bits I am using. Right? 45 times, every time 8 bits. But here 45 times, every time 1 bit only, that is 0. Right? Now next one, can you help me now? What is the B frequency? Somewhere here also there also there. B frequency 3 into. Right? To represent 3, how many bits? 4 bits. Next one, can you help me? What is the C frequency? C frequency, see somewhere there, here, 30. To represent C, how many? 2 bits. Next one, what is the D frequency? D frequency, 1. To represent 1, how many bits? I think 5. Next one, what is E frequency? E, I think 20. 20 or 30? 20. Right? For the E, how many bits you are using? 3. Next one, what is the F frequency? 1. To represent how many? 5 bits. Just add total. How much? 45 only. 45 plus 12. 45 plus 12. How much? 45 plus 12. What is the answer? 59. 57. That's okay. 45 plus 12. This is completed. 57. Next one. 60. What is the answer? 7. 117. Next one is 5. 122. Next one is 60. Next one is 62. 182. Next one is 5. 187. Right? I think total 187. Calculate properly. I done roughly. Right? So because of every no calculations, I done roughly. So can you say total bits how many? 187. I am calculating again. 45 plus 12. 57. Next one. 57 plus 60. What is the answer? 7. I think 117. Afterwards 5. 122. Afterwards 60. 182. Afterwards 5. Right? 187. So total 187 bits. See this one? Total bits are 187. You have to transfer. Can you say what is the average? Average is equal to 187 by total number of characters. How many? This one, 100. This number, please be careful. Some people are always dividing by 100. No. In this problem, 100. In the next problem, maybe total may be 97. In the next problem, total may be 105. Whatever there, just do that. So, average is going to be 187 by 100, which will goes to 1.87 bits per character. Please be careful. This is average. This is average. Total bits is going to be, right? So, A repeating 45 times, right? But to represent A here 1 bit only. B repeating 3 times to represent here 4 bits. C repeating 30 times, right? To represent here 2 bits, like that. If you add all of them, 187 bits. Average is going to be 187 by, right, total number of characters divide 1.87. In Huffman coding, these are the 2 questions which you can expect. What is the Huffman code for every character? Next one. Total number of bits how many? Which is nothing but average how many? 1.87. And one more, let's see the interesting answer. Without Huffman coding, what is the average? 8 bits per char. Total 800 bits you have to transfer. But using Huffman coding, what is the answer? Right? Only 187 bits you transfer. Average is 1.87. Previously average is 8 bits per character. Now here only maximum, see this one, more, right? Less than 2 bits only, 1.87 bits per character. Right? Please, this is the Huffman coding style. Some students are asking me one small line. How Huffman coding is able to compress this much, right? Let's listen this also. How Huffman coding compressing this much, right? I will say now. See this one, I will say. Can you help me one small line now? This is the ASCII representation. This is the Huffman code representation, that is okay. But if you observe clearly, right? In the ASCII representation, for every person to represent 8 bits you are using. In ASCII representation, for every person to represent 8 bits you are using. Is it right or not? But in the Huffman coding representation, right, it is not uniform coding. Here every person to represent 8 bits, but here A representing 1 bit only, B representing 4 bits, C representing 2 bits. What is the meaning? ASCII representation is uniform coding, but Huffman coding is not uniform coding. What is this one? It is a non-uniform coding. It is a non-uniform coding. It is a uniform coding. That is the first difference. Right? Why is having more, why is having less is, right, first property. It is going to be uniform coding. It is a non-uniform coding. Please be careful. If you want to save resources, right, you cannot treat everyone same. Please be careful. That is a fundamental rule. You want to save something, don't treat everyone equal. If you treat everyone equal, this is the story. Right? Treat differently. That is the first thing what you have to take care. And one more. This is the non-uniform, this is the uniform, it's okay. But one more interesting thing is, see this one. One more interesting thing is, right? See correctly now. One more interesting thing is, Huffman coding is following one nice strategy. What is that one? Can you say in all these people, A is having 45 frequency. See correctly this also. A is having 45 frequency, C having 30 frequency, E is having 20 frequency. What is the meaning? Remaining people are also having frequency but very less. See this one. A having 45 frequency, C having 30 frequency, E having 20 frequency. But if you add all of them, total 800 came. Try to remember, total 800 came means majority contribution came from A, C, E. Other people are given very less contribution. If you want, you can check. Out of 800, F given only 8. Out of 800, D given only 8. Out of 800, B given only 24. But A is given, see, so 45 into 8, how much? 8 4 is 32, right? 8 5 is 40, I think 360 given by A only. 8 4 is 32, means 320, 8 5 is 40. So 360 out of 800, almost like 360 given by A only. Next one, out of 800, right, 30 into 8, what is that? 8 3 is 24, 240 given by C only. Out of 800, 160 given by E only. What is the meaning? Majority contribution came from A, C, E. Why? They are having more frequency. So in ASCII representation, everyone you are treating same. And one more, major contribution is came in this 800 from A, C, E. What is the meaning? More frequency people are generated, more values. That is the reason 800 came. So what is the Huffman coding doing the great logic is? See this one. What is the Huffman coding? Can you help me? Who is having more frequency? A, C, E. These three people are having more frequency. Huffman coding logic is going to be, right? Non-uniform coding you want to follow. I am writing here. Huffman coding logic. See this one. Huffman coding logic is going to be first non-uniform coding. That is the first thing what he is following. One more thing, see this one more interesting thing, non-uniform it's okay, but one more interesting thing is going to be, these are highest frequency people, careful listen, these are highest frequency people. For higher frequency people, he will give less bits. If you want, you can check. A having 45, what about C? C having 30, what about E? 20. Can you help me now? Among all these people, who is having more frequencies is one A. A is having more frequency, Huffman coding will give less bits to that, see, 1 bit only. More frequency person, Huffman coding will give less bits. Please be careful. Can you see who is the next more? Next more is C. I think C, next more bits. I think he is having less bits, 1 bit only. Next more frequency is C. He is having next minimum. Here next minimum bits. Here first minimum bits. Here next minimum bits, 2 bits. Who is the next more frequency? E. E is having next minimum bits, 3. If from today onwards, if anyone asks you, Huffman coding logic, what will you say? It is a non-uniform coding, but one more major logic is going to be, higher frequency people give less bits. Higher frequency people give less bits. Some people are asking, for higher frequency people, if you give less bits, what about lower frequency people? Lower frequency people may get more bits, but anyhow they are lower frequency. It don't affect. Effect will be done by higher frequency people only. Why here 800? Higher frequency people also you are given 8 bits. Lower frequency people also you are given 8 bits. Everyone giving big number, that is the reason 800 came. But here what he will do is, right, higher frequency people he will try to give less bits. So, problem solved. You may say that, what about lesser frequency? Lesser frequency maybe if you give more bits also no problem. Give next more bits, right? No problem, because anyhow they are less, they don't affect. This is the idea. Now say something about Huffman coding. It is a data compression technique, yes, compressed. Next one, it is the data encoding technique. What is the meaning? A not stored as A stored as 0. B not stored as B stored as 1001. It is a encoding technique, it is a compression technique also. If anyone asks you how compression is going on in Huffman coding, what will you say? It is a data, can you help me? It is a data, sorry, it is a non-uniform coding technique, and one more, higher frequency people will give less bits. That is the idea. Side effect may be, right, lesser frequency people may get more bits, anyhow there is no problem. Because small people may not affect, bigger people only will affect, right, like that. Right, I am thinking that until now everything is fine now. Let's see how this diagram came. Can you help me now? How I constructed this diagram? Say this point also. How I constructed this diagram? How I constructed this diagram is, I am taking, see this one, I am taking 2 minimum, 2 minimum, 2 minimum, 2 minimum I am taken. Like that I constructed tree. You only say, if you take 2 minimum, 2 minimum, 2 minimum like that, if you construct a tree, who is the bottom of the tree? Lesser frequency. Who is the top of the tree? Higher frequency. If the top of the tree is higher frequency, if you give code from the root, they will be close to root. See this one, in the tree, who is the bottom of the tree? Lower frequency, because 2 minimum, 2 minimum, 2 minimum, 2 minimum, lower frequency people at the bottom. Higher frequency should be close to root. You are giving code from close to root, you are giving code from root only. Because of higher frequency people close to root, they will get less bits. What is so great in that? So Huffman coding is very clear. What is that? Higher frequency, less bits. So higher frequency people should be close to root. That means lower frequency people should be bottom of the tree. So tree construction start from smaller. Take 2 smaller, take 2 smaller, take 2 smaller. At the end, what is the answer? Larger also will come. They will be close to root. From there only code is given. So higher frequency people will get less bits. This is the idea. Suppose higher frequency people you want to give more bits. Lower frequency people you want to give less bits. Then what is the answer? Higher more you want. Then what is the answer? Take 2 bigger, take 2 bigger, take 2 bigger, and so on. If you take big, something like that, bottom of the tree contain big people, right? Close to root contains small people. From root if you give code, right? Smaller people will give less bits, right? Higher people will get the more bits. It is up to you what logic you want. Huffman coding logic is what? Non-uniform coding, higher frequency will get less bits. Right, let me write this. I already written, see this one. Huffman coding, what is the one logic? Non-uniform coding. That is the one logic. What is the one more thing? See this one more. Higher frequency, less bits. Less bits. This is the one more. These are the two major points of Huffman coding. It is a non-uniform coding technique, and one more, higher frequency will get less bits. How? So less, 2 minimum, 2 minimum, 2 minimum, 2 minimum, close to root maximum. From the root only you are giving code, less bits. So bottom of the tree contain less frequency, so more bits. What is there in that? So that is the idea, right? From now onwards, see, Huffman coding, any question will come. What is the question number 1 expected? What is the Huffman code for every character? Question number 2, what is the average number of bits required, right, to transfer this message, right? Just to do like that. What is the first step? Draw the tree. Afterwards, Huffman code for every character you write, right? Based on that total bits you find out, divide by how many bits are there, so how many characters are there, you will get average. So next problem onwards, do only Huffman coding. See this one. Next problem onwards, do only this area. This only required. It is very, very interesting one. Say 4 things about Huffman coding. First one, encoding technique. Second one, data compression technique. Next one, it is a non-uniform coding technique. Major logic, higher frequency, less bits. Side effect, less frequency people may get more bits, still no problem. Why? They will affect very less. Without Huffman coding, so see this one, 800 bits have to transfer. With Huffman coding, only 187. Average previously 8 bits per character, but here average, what is the answer? 1.87. Right? I'm thinking you are almost okay. Right, fine. Now to get the more clarity, let's see example 2 also, you will get more clarity. Right? After example 2, you feel so comfortable. Right? Fine. So Huffman coding example 2. Huffman coding example 2, let's start. You know very well Huffman coding problem, all necessary things let me write. See, I am writing message M contain M1, M2, M3, previously A, B, C, D, now M1, M2, M3, M4, M5, M6, right? So totally I think 6 people. Next one, let me give the numbers. See this one, let me give numbers. The 20, it is 3. At the 10, at the 11, at the 12, it is 30, some numbers, 20, 3, 10, 11, 30, 12, this one, right? So the question which is going to be asked here is, right? So on this problem, if you apply Huffman code, what is the Huffman code for every character? That is the question number 1. Question number 2 is going to be, what will be the average number of bits required? Only for Huffman coding, not before Huffman coding, not after Huffman coding. On this problem, if you apply Huffman code, what will be the Huffman code for every character, right, or for every message? See, big message M is equal to small messages M1, M2, M3, M4, M6. Message M1 repeating 20 times, message M2 repeating 3 times, and so on. Now, if you apply Huffman code, right, what will be the Huffman code for every message? Next one, what will be the average number of bits required? So I will start now. Listen, I'm really saying to you, in the first problem, you cannot get everything. One small mistake is going on from your side. With the help of this problem, I will clarify. Previously also I said, but you didn't get. Now you will get. Can you help me now? To this problem, if I want to apply Huffman coding, see this one. To this problem, if I want to apply Huffman code, what should I do now? What is the first step? If I want to do Huffman coding on this one, what is the first step I have to take? 2 minimum. Can you help me now? Take 2 minimum. Next, take 2 minimum, you will add them, you will keep inside. Again 2 minimum. Try to remember, always if you want 2 minimum, you always remember. If you always want 2 minimum, best idea. Always you want minimum with the cheaper cost. If you want, then go to mini heap. That is the purpose of mini heap. That is the reason I completed the mini heap tree, max heap tree first. If you want always minimum, then go to mini heap. If you want always maximum, then go to max heap. Can you help in this problem? You want 2 minimums, 2 minimum, one time or many time. If one time required, you can go anyway. No objection to me. If one time only required minimum or maximum, you go whatever way you want. If many times required, then go to min heap. Many times maximum, then go to max heap. Many times minimum, then go to min heap. One time only required, you can do whatever you want. Suppose I want one time only minimum, then what is the answer? One time only minimum. Selection sort first pass apply, you will get minimum. Order of n, one pass. If you want one time maximum, what will you do? Bubble sort first pass apply, you will get the maximum. If you want only one time minimum, selection sort first pass. One time maximum, bubble sort first pass, which is nothing but finding maximum minimum. If you want many times minimum, go for min heap. Many times maximum, then go to max heap. Please be careful. In this algorithm, you know very well, 2 minimum, many time, then go to min heap. Right? That is the reason I am going to min heap. Please be careful. One time don't go. Many times required, then go to min heap. Some people are asking, sir, one time if I go to min heap, what is the problem? Right? One time if you want min heap, one time if you want minimum, if you go to min heap, if you go to the selection sort, right, both will be similar. No advantage also. If you want to get advantage, many times minimum, min heap. Many times maximum, max heap. One time minimum, selection sort. One time maximum, bubble sort. Right? Please be careful. Here many times minimum is there. So I am going to min heap. So I am starting. Right? I am starting. Carefully listen. I am starting. So because of I always want minimum, see this one, for all these people, right, apply build heap. Can I help you now? N people creating min heap, how much time? N time using build heap method. N people, isn't that N people here? N people to create min heap, right, using build heap, N time. So build heap method, using build heap, create min heap, order of N time. Assume that N messages are there. Big message M is equal to, right, N message, N small messages, 1, 2, 3, 4 like that. So for all these people, right, using build heap, create min heap, order of N time is over. Next one, after order of N time is over, I have min heap, you know build heap method, that is the reason I am not doing, right, build heap method using create min heap for these people, order of N time is over. Next step is going to be, because of it is a min heap, next step is going to be delete first time. Who came? First minimum, who is that? M2 came, value 3. Delete second time, who came? After 3, who is the next minimum? 10, I think, M3. What is the value? 10. These two people came. Right? These two people came. Right? These two people came. 2 times I deleted, 2 minimums came. These are came, let me cancel it. Can you help? 2 deletions will take how much time? In the min heap, N people are already there in the min heap, deletion will take log n time. 2 deletions, 2 log n. Right? I will write within a few minutes. Delete 2 times, who came first? First minimum left, second minimum right. This is 2, this is 3, this is 10. Right? Add both. How much? 3 plus 10, how much? 13. Right? After getting the 13, insert 13 again. Please be careful. 2 deletions, yes. 1 insertion. Who is the inserted value? 13k. So 2 deletions and 1 insertion, totally 3 times 3 operation, 3 log n. 1 insertion is log n, 1 deletion is log n. So 2 deletions, 1 insertion, totally 3 log n. This is the current status. 2 times delete, 2 log n, 1 insertion, 3 log n total. First create min heap. If min heap not there, you cannot do this. This is the current status. Now can you help? Previously how many people here? 6 people. Now out of 6 people, 2 out. It became 4. 1 person came in. Totally 5. Let's check here. 1, 2, 3, 4, 5. Totally 5 people. Again continue the same story. Same story should continue. Same story. What is the meaning? Delete 2 times. 2 minimum. Min heap tree, if you delete, minimum will come. In the available people, minimum. This is the mistake what some people are done. Can you help? In the available people, minimum. Who are those? In the available people, minimum is not 13. In the available people, minimum is 11. Please be careful. Minimum 11. Please be careful. M4, 11. Next minimum, I think M6, 12. These are the 2 minimum. Please be careful. So next 2 minimum. First 2 minimums are 3, 10. I done already. Next 2 minimums are 11, 12. Not 13, right? See, this 13 is waiting, but he is not came back. What is the meaning? Next minimum is not 13. That is the reason he went. He went, if at all is minimum, he will come back. If he is not minimum, he will stay there only. Always 2 minimums required. So 11, 12. 11, 12 and this diagram no relation. It is a separate diagram. You can write wherever you want. Let me write here. M4. Wherever you want, you can write M4. But one thing, while writing, left smaller, right bigger. Please be careful. M4, M6. this is 11, this is 12. That is the reason I given this problem. If anyone thinking this kind of mistake, please take care. It will become 23. Let me insert 23 inside. 23, 2 deletions, 1 insertion, again 3 log n. Every time 2 going, 1 coming means 1 only going. Please be careful, 1 only going. So who are out now? I think this is out. This is also out. But E came inside. So 2 times you done until now, 3 log n, 3 log n. Now once again, delete 2 times. 2 minimums required. Who are the 2 minimums? Please check. D1, D2. First deletion, second deletion. In the available people, who are minimums? Let's check here. One is 20. Another one 30, another one 13, another one is 23. Available people better. I think 13 is better and 20 also better. Please check. 13 and 20. So 13, right? D1 is the first minimum is D1. Second minimum is D2. Who is that? M1, 20. So 13 and 20. Now see the interesting answer. 13 and 20. I think 13 already there same person came back. It's okay. Next one 20. I think 20 is right side, this side. Right? M1, 20. Add this one, it will become how much? 33. 33 inside. Again it will become 3 log n. Whom you deleted, let me delete it. 13 is out, 20 also out. That is also 3 log n. Once again delete. First deletion, second deletion. Can you help me know first deletion, what is the answer? First deletion, what is the answer? In the available people, best people check. Can you see who is available first? First read 30. 23, 33. Best one, I think 23, 30. 23 and 30. 30, what is the number? M5. Name is there, write the name. Name not there, write as 23, 30. Right? These are the 2 minimum. Can you help me? Where is the 23? Here. 30, this side. I think M5. It is 30. Add them. Which will goes to what is the answer? 53. 53. Right, so let's check here, 53. Again it is a 3 log n. Can you see whom you deleted? I think 23 out, 30 also out. Now available people 53, 33. See this one, 53, 33. Now see that, take care. 53, 33. I am deleting. First 33 will come, next 53 came. See this one, while adding, while combining, take care. Left smaller, right bigger. See, left 33 there. Right 50 there, you can combine. Suppose reverse there, you have to reverse it. Reverse there, you have to reverse it. Please be careful. So left should be smaller, right should be bigger. See this one, while combining, left should be smaller, right should be bigger. Please be careful. If you combine blindly, right, left is bigger there, right is small there. I think try to remember 0 becomes 1, 1 becomes 0. Coding time problem will come. Right? Coding time problem will come. Please be careful. While merging, always you take care. Left smaller, right is next smaller. Left smaller, right is going to be next smaller. If reverse happened, code reverse will happen. Please be careful. So I think now you are, until now I didn't bother. See, everywhere you check. Left smaller, right next smaller. Left smaller, next right, next left smaller. Left smaller, right next smaller. Like that I done. So I think now I can merge this. How much it is becomes? 86. Check once. 86. Right? Let me insert 86 inside. When you insert 86, 33 is out. 53 also out. Only one person stop. 2 people required. To do this work, 2 people required. Only one there, stop. Can you help me now? 6 people there. How many times you done? 5 times. Why? Every time one going out. Every time one going out, one going out, one going. 5 times I done. 5 people out. Only one person left out. Stop the story. This is called as two-way Huffman encoded tree. This is. Next one, what will you do now? After completion of this tree, what will you do? Just give the code. How to give the code? What is the answer? Left 0, right 1. If anyone do, left small should be there, right will be next smaller. If anyone do reverse, I think code will be reverse. Please be careful. Left 0, right 1. Left 0, right 1. Right? After tree construction over, just give the code like this. Now after giving code, let's start one by one. Can you help me now? Huffman code. Huffman code for every character. Can you say what is the M1 code? Start from root. Where is the M1 check? Start from root. Where is the M1 check? I think M1 here. What is the answer? 0, 1. Can you say M2? M2. I think 000. M3. M3 this one. I think 0, 0, 1. M4. M4 1 0 0. Next one M5 1 1. Next one M6 1 0 1. Right, like this is the Huffman code for every character. Next one, this is the question number 1, you know. What is the average? Let's check same way. How to find out average? Can you say M1 frequency? Please check. Right, M1 frequency 20 into 2 plus M2 frequency 3 into 3. Next one, M3 frequency 10 into 3. Can you say M4 frequency 11 into 3. Next one, M5 frequency 30 into 2. Next one, M6 frequency 12 into 3. Like that. Yeah, total. Whatever will come, right? Whatever will come. Let's count here. 40 plus 9, 49. I think it is 30. This is 40. This is going to be 30, 70, 79. Right? Let me write now. 79 until now. This is completed. This is completed. It is 30, it is going to be 40, 70, 3 into 3, 9, I think 40 plus 30, 70, 79. Next one is going to be 60. Next one is going to be 36. Next one is going to be 33. Just add all. You know very well additions and all. 12, I think 18. Right? 4, 7, 13, 20, 208. Check properly. 208. Right, this is the total. Right, average is what? By, see this one, 208 came, isn't that? Just add properly, isn't that 208 came? 208 by, right, this 86. That will give average. 86, don't write every time 100. 86, right? What is this one? Bits per message. Previously character, now messages, right? M1 is a one small message, M2 is a small message. Bits per message, right? 208 by 86, whatever calculation is there, do that. It is there in the option, keep as it is. Otherwise, right, calculate, right, simplification is there, simplification you do. Huffman code for every character. Next one, question number 2. Average number of bits per message, 208 by 86. Right? So this is the interesting thing. Some people are asking me, why are you doing mini heap here? Always you want minimum. If you want only one minimum, selection sort first pass. If you want only one maximum, bubble sort first pass. If you want many times minimum, mini heap tree. If you want many times maximum, max heap tree. Please be careful. So, right, so these two questions you can expect, right, fine, that is also okay. Now see the answer, because of you done really nice work, everything available on the board also. Please see correctly. Time complexity of, see the answer, time complexity of Huffman coding is equal to, see the answer, time complexity of Huffman coding is equal to, can you say what is the first step? Create min heap using build heap method, n time. Next one, what is the answer? 3 log n, 3 log n, 3 log n, how many time? N minus 1 time, n minus 1 time, every time 3 log n, which will goes to n plus n log n, forget about minus 1 plus 1, n into 3 log n, means n log n, finally n log n. Time complexity of Huffman coding is n log n. Right, check properly. This is the second example. Every time take 2 minimum, 2 minimum. Some people, the expected mistake is going to be here. Some students, what they are doing is, one time only they are taking 2 minimum. Next time they are not taking 2 minimum. No, every time 2 minimum. Take 2 minimum, result keep inside. Right, after keeping inside in the min heap, when you delete second time, 2 times if you delete, automatically actual 2 minimums will come. You don't do anything with your eyes, do everything with brain. If you see with eyes, right, you may take wrong thing, right? Take 2, first create min heap, delete 2 times, whatever he will give, take. Delete 2 times, 2 minimums, right, add them, right, whatever value came, insert again in the min heap. After inserting, again try to delete 2 times, he will give always 2 minimum. But while adding, left should be first smaller, right will be next smaller, right? Suppose isn't that, the things which are coming 2 minimum, no relation with the previous tree, then create somewhere. So this will also grow, this will also grow, this will also, lastly you have to combine. While combining, please take care, left will be smaller, right will be next smaller. Combining time, take care, left smaller, right will be next smaller. If both are growing, see this one in the this diagram, if you see, this tree is growing, some point of time, lastly definitely one tree should come, You cannot get disconnected 3. Lastly, you have to combine. Combining time, left smaller, right will be next smaller. Please be careful. I'm thinking you are okay. Let's see one more example for Huffman coding. Message M is equal to A, E, I, O, U, S and T. Next one, A frequency 0.23, E frequency 0.05, I frequency 0.32, O frequency 0.11, U frequency 0.04, S 0.06, T 0.03. Right. Can you help me know what the first step? Create min heap. Creating min heap using build heap, n people, n time. Assume that n people are there, so n time. Right. Next one. So min heap tree saying that, Huffman coding saying that always take 2 minimum, delete first time, delete second time, 2 minimums will come. If you delete first time, who will come? Who are the smaller among all? Who are the smaller among all? What is the answer? I think 0.03 smaller. Please check. Right? Can you say next smaller? 0.04. First smaller is T, 0.03. Next smaller is going to be U, 0.04. Please verify. 3 and 4. Fine, that is perfect. So let me write now. So what is the answer? T left side, U right side, 0.03, 0.04. Add these two. What is the answer? 0.07. So inside 0.07 inside. Total 3 log n. 2 deletions, 1 insertion. Right? Whom you deleted, delete it. Like this. Next again, same story. Again same story. Delete twice. Can you help me? Delete first time, delete second time. If you delete first time, who will come? In the available people, first minimum. I think 0.05 E, 0.05. Next one is going to be, I think S also, 0.06. Please be careful, 2 minimum in the available people. And one more, these 2 people and this tree, no relation. See this, no relation. So it will grow separately. But one thing, while combining time, so left smaller, right bigger. Left smaller, right is going to be next smaller, 0.05. Next one, S, 0.06. Draw wherever you want, because of it is a separate diagram, you can draw wherever you want. It will goes to what the answer? 0.11. Right? 0.11. It will going to be 3 log n. Right? Again, can you help me now? In the available people, again delete 2 times. So what are the things I have to delete? 5 I have to delete, 6 also I have to delete, it is the current status. Now in the available people, delete 2 minimums again. Check who are the 2 minimums. Please verify who are the 2 minimums. Who are the 2 minimums? If you observe, I think this 0.11 is there, this 0.11 also there, 0.07 also there. I think next 2 minimums are going to be, you can take either this 0.11 or this. Anything you can take, there is no objection at all, because of you have the choice. 0.07 already there, 0.07 already there, 0.11 also already there. You can merge these two also. One more way, this 0.77, this 0.11 also you can take. Both are okay. I think 2 diagrams will come, two different answer. In exam, right, you will take care, don't worry. Let's give one answer here. 0.77, let me delete here. 0.071 and one more is 0.11. Right, these 2 things I am merging. Which will goes to what the answer? 0.18. 0.18. So I am deleting. Because of 2 0.11, you can take this also. Both are okay, there is no objection. 3 log n. 2 answers will come, other than this nothing there. If you take that one answer, if you take this one answer. You will take care in the exam. In the exam, only one answer will be there. If 2 there, both will be there. Don't worry. So I think it is the current incident now. Let's delete. Right? So in the available people, again check 2 minimums. First of all, who is available? 0.23 available, 0.32 available, 0.11 available, 0.18 also available. In the available 2 people, who is better? 0.11, 0.18. I think now this will come. O, which will goes to 0.11, it is 0.18, which will goes to 0.29. This will be out, this is also out. Again it is 3 log n, that's okay. So who is out here? 0.11, 0.18 out, right? 29 is K. That's okay. Next one, can you help me in the available people? Again, next better people. Who are those? Check. 0.23, 0.32, 0.29. Who is that better? 23 and 29. 23 and 29. I think 23 this side here. Right here, check A. 0.23. 29 already there. So what is the answer? If you add these two, so what is the answer now? I think 0.52. Check. Right? Fine. What are the things? 0.23, 0.29 we added, right? So 0.52 is came inside, 3 log n. So let me delete, 23 is out, 29 also out. And the remaining people, who are those? 32 will come, right? Next one is going to be 52 also will come. 52 also, let's check. So what is the name of this one? I, which will going to be 0.32. Add these two, how much? 0.84. Inside 0.84 will come, cancel these two things. Right? I think if you observe 6 people, I think 5 times you done these 2 and those 3. Totally 5 times you done. See this one? Time complexity for Huffman code, which will goes to n for creating mini heap, n minus 1 time, every time 3 log n. Finally, n log n. Right? But here, so let me complete formalities. This is the Huffman encoded tree. Huffman encoded tree. Please be careful. You know how to create tree. Always take 2 minimum, 2 minimum, 2 minimum like that. Next one. See the interesting answer. Always take 2 minimum, 2 minimum. You create 3, everything fine. I am thinking you are absolutely fine. Let me say this fact which is pending also. See this one. In one of your previous paper, one Huffman coding problem is given, that is okay. In that problem he mentioned one more, right? After creating Huffman encoded tree, assume left edge labeled by 1, right edge labeled by 0. Please be careful. It is not always left 0, right 1. In the problem he may change. While doing Huffman encoded, right? While doing Huffman encoding, assume that left edge labeled by 1, right edge labeled by 0. If he say, you have to follow that. Suppose if you say left 0, right 1, you have to follow. If you don't say anything, right, anything may be possible. Right, not by default left 0, right 1, right, anything possible. It is not compulsory to keep left 0, right 1, right, problem to problem you will change. If you say left 0, right 1, follow. If you say left 1, right 0, follow. If you don't say anything, do whichever you feel, right, suppose that, right, he is not mentioned, left 0, right 1 you done, assume. In the option, no matching there, maybe reverse there, please check. You know, right, while writing, when I am writing gate examination, that time same kind of problem there, he is not given anything. I done left 0, right 1, I completed, nowhere answer is there. So, I done reverse, option A is matching, still I remembered. You may say that sir it will take more time, for all the people same. Not only to you, for all the people same thing, that is the reason. Right? So, let us see this one. After completion of this, I am writing this also. See this one. See correctly? Assume. So that you will remember. Assume left is 1, right 0. Assume left is 1, right 0. Let me follow. Otherwise, you may think that every time is same. That is the reason I have given this. Assume left 1, right 0. Right. Now can you help same way. What is the Huffman code for every character? M, right, M1 or A? Let me write here. A, E, I, O, U, S, and T. Right, let's start. Can you help me now? What is the A? See this one. In this diagram, where is the A? Check. I think A. What is the answer? 0, 1. What about E? What about E? I think 4 zeros 1. E 4 zeros 1. Next one. What about I? A E I O U. What about I? 1. What about O? 0 1. What about U? What about U? 3 zeros 1 0. What about S? What about S? What is the answer? S, what is the answer? I think 4 0, I think 5 zeros. Please check. 5 zeros. See this path. 3 zeros, 2 zeros. What about T? T, 00011. Right, like that. Please check properly. That is the question number 1. What you can expect. See the question number 2. See the question number 2 here. And one more. Before going further, I want to say one thing. Okay, listen. I want to say one thing. This also you listen. This also you listen. See everyone. Can you help me now? In the ABC string, what are the prefixes? In ABC string, what are the prefixes? Right? For the ABC string, what are the prefixes? A prefix, AB prefix, ABC prefix. Set of all leading symbol. Set of all leading symbols is known as prefix. A, AB, ABC. These are called prefixes. Please be careful. These are prefixes. Please be careful. Some students are asking, why are you saying this? What is the reason? See, this is the reason for that. This is the reason. So, these are prefixes, it's okay. Now listen, if you want, you can check. Right? Can you help me one small line now? See this one. I code is 1. See everyone now. See correctly now. I code is 1. I code is 1. See the interesting answer. ABC prefixes are A, AB, ABC. That is okay. Right? Now see this one. I is 1. I is 1. If you want, you can check. I code is 1. That is fine. If you want, you can check. No other person code contain prefix as 1. Please check. I code is 1. Right? So I is saying that my code is 1. But everyone saying that no one contain prefix as 1. Please check. No one contain. So what Huffman coding is following one great property. What is that one? No character Huffman code is prefix of someone else Huffman code. Please be careful. No, I am repeating once again. No character Huffman code is the prefix of, right, someone else character. Please be careful. If at all it is there, serious problem. Decoding time problem will come. Decoding time problem. Some people are asking decoding time how problem. So 1 means I only now. Whenever someone will say 1, what is the meaning? 1 means I only. Suppose someone else character contain Huffman coding starting 1. So I also 1. Someone else also having starting as 1. So we have doubt. We have doubt. This 1 means should I take I or should I take that one? Please be careful. That is the reason Huffman coding another name is called as optimal prefix notation. Optimal way of keeping prefix. If I keep prefix in such a way that, right, no problems will come. At the same time, right, compression means you cannot do whatever way you want. If you do compression whatever way you want, right, decoding time problem will come. If you don't want decoding time problem, right, no character Huffman code is prefix of someone else Huffman code. Please be careful. If at all, one character Huffman code is prefix of someone, decoding time I don't know whether I have to take that character or this character because both are matching. Now, those people who are not getting this point, right, again I am repeating. See this one again. Please see the interesting answer. Listen, character A, what is the Huffman code? 01. Character A, Huffman code is 01, that is fine. If you want, you can check. No other character prefix contain 01. See this one? 00, no 01. Prefix means what? Starting only. 01, nowhere. Please check. No, see this one. One character Huffman code cannot be prefix of someone else Huffman code. See this. No one contain 01. No one contain 01. And one more interesting answer. See this one. So, O Huffman code is 001. O Huffman code is 001. No character Huffman code contain prefix as 001. Please check. 000. But it is 001. 000. It is 00. No one like that. This is called as, that is the reason Huffman coding is called as optimal way of keeping prefix. Optimal prefix notation. Let me write here. Optimal prefix notation means optimal prefix notation, indication that no character Huffman code is prefix of someone else character Huffman code. Optimal prefix notation. Huffman coding and optimal prefix notations both same, right? Don't confuse. Okay, that is fine now, right? See the second now. Total number of bits. Total bits followed by average. You know how to calculate. That is also, this is the first question, it is the second question. So you calculate yourself. See the third one. Everyone can do this calculation. See the third one, interesting one. See the interesting one. Make sure that everyone listen. Interesting one. To say this point only, I given this problem. Not remaining things. If I done at anywhere small calculations problem, please you take care, right? So to say only third point, I given this problem. I am giving now. See this one, I am giving. See this one. See correctly now. Encoded message. Encoded message is, careful listen. Encoded message is going to be, let me write here. Encoded message is going to be 000 101 000 111 001 01 111 00011. This is the encoded message, right? Some people are asking, this is the encoded message, it's okay. What is the decoded message? What is the decoded message, right? How to give, I will explain now. To say this problem only, I give in this. It is very simple also. Encoded message is this one, decoded message. What is the meaning of decoded message? In terms of A, E, I, O, U, S and T, it should look like. Actual message is A, E, I, O, U, S and T. After encoding, it came like this. If you decode, it should come like A, E, I, O, U, S and T format. Some people are asking, sir, how to get it? I am doing this. See this one, how to get it? Very simple. See the answer, very simple. Can you help me now? Right? Can you help me one small line? Assume left is 1, right 0. Please be careful. Assume left 1, right 0. Please be careful. I am starting. Right? What is the decoded message? Assume left 1, right 0. Let's start. See the encoded message. See the encoded message is this one. Right? See this one. 0 means what? 0 means right. Careful. So start in the tree. In the tree, what is the answer? 0 means right. Again 0 means right. Again 0 means right. 1 means left. Next one, 0 means right. See this one. Start from root, right? 0 means right, like it's okay. 1 means left, it's okay. 0 means right, it's okay. When you going like this one, leaf node came, stop. What is the name? U. Just keep the U. This is U. Please be careful. Like that you have to do decode. So some people are asking, sir, how it is? Everyone knows this is came same way. These all came by doing like that only. Same thing you are doing, nothing. Once again, after getting the leaf node, keep the name U. Again start from root. Can you help me start from root? What is the answer? 1. What is the answer? 1 means go left. I think I came. Directly I is came. This is I. Next one, again start from root. 0 right, 0 right, 0 right. Next one, 1 left. Again 1 left. What is the answer? TK. 00011 TK. Please verify yourself. Again start from root. 1, what is the answer? Left, IK. Next one, start again from root. 0, 0, 1. What is the name? 0, 0, 1. What is the meaning? O. Okay. Next one, 0, 0, afterwards 1. 0, 1. What is the meaning? A. Next one, 1, I. Again 1, I. Again 1, I, like that. Next one, 00011. What is the meaning? 00011. What is the meaning? T. Like that you have to do decode. This is the decode message. UIT IOA IIIT. This is the, to say this problem. In this problem, new thing is third point only. And one more. Somewhere if you observe, 0.1 is twice there. 0.11 is twice. Right? So, two minimums, 0.07, 0.11. This also you can take this also. If you take this one answer. If you take this one, another answer. Only one answer is there in the option. Don't. Whenever choice is there, take whatever you want. Right? Time complexity is same, n log n. Why n minus 1? Every time is 1 only going. N minus 1 times you do. N minus 1 people will go out. Lastly 1 left. See, lastly 1 person left out. Right? See this one. Lastly 1 person left. Only 1, stop it. Time complexity you are okay. And one more. Why are you using min heap? Every time you want minimum. Many minimums, mini heap. One minimum selection sort, first pass. Encoded message they will give you, they will ask you decoded message. How you got this? Right? By following from root. Same way you do. But one thing, if you want to do decoding, right? You should know this. Right? He will say in the problem, please read it. Accordingly you follow. Average you know how to find out. First two things, first one, second one. See this one, first point, second point in the previous two problems I covered. In this problem I want to cover this. I done this. Right? Fine. Thank you. This is the Huffman code. Next application of the greedy technique after Huffman coding is going to be optimal merge pattern. In this optimal merge pattern, I written also on the board. If you want, you can check. See this one, optimal merge pattern. That is the next application. In the optimal merge pattern, first example I am explaining. Please see, n is equal to 3 means 3 files there. Those names are given x, y, z. But when you say file, collection of records. See this one, file x contain 100 records. 100 records. Please see. File y contain 150 records. File z contains 70 records. Right? Please be careful. This is the input. Right? In optimal merge pattern, first example I am explaining, n is equal to 3 means 3 files there. Names are x, y, z, where x contain 100 records, y contain 150 records, z contain 70 records. Right? 70 records. And one more thing. Right? So x contain 100 records. Right? All are sorted based on some parameter. When you say file, in that 100 records are there, right? Everything is sorted based on some parameter. It is something like this one. It is something like, assume that you are studying 4th year engineering. Assume you go to your college department. You simply ask them, please give my batch file. You are studying 4th year engineering in one of the college. Assume that you go to your department and you ask, right, can you give my batch file? They will give your batch file to you. If you open, right, for every student in that file, one record will be there. Record doesn't mean that big story and all. Record maybe, I think for every student they may manage 2 or 3 pages. Right? So roll number 1, 2 or 3 pages, one record is there. Roll number 2, 2 or 3 pages, one record is there. Like that. Collection of records is known as file. All are based on, right? Definitely when you say it is a file, records are there, all those records are sorted based on some parameter. Maybe roll number wise, maybe alphabetical order, maybe percentage wise, right? Based on some parameter they will sort. When you say file, it is a collection of records, right? When you say many records are there, they all will be sorted based on some parameter. So assume that x is a file which contain 100 records. All these records are sorted based on some parameter. Maybe assume that roll number wise. Y contain 150 records, Z contains 70 records, something like that. Now, as the name suggesting, see this one, optimal merge pattern. As name suggesting, optimal merge pattern. What is the meaning? You have to make these three files as single file. That is the meaning of merging. As name suggesting, you have to make all these 3 files as single file. Means you have to merge. Some people are asking, sir, how to merge, right? Take two people merge. That is called two-way merge pattern, right? So listen everyone now. He will say in the examination two-way merge pattern. Suppose that many are there. He may say in the problem three-way merge pattern. What is the meaning? Take three files and merge. Two-way merge patterns, if you know, right? You know three-way also. If you don't mention, go to the two-way merge pattern. Normally, you will mention using two-way merge pattern. He may say like that. If you don't say, try for two matching, that will be the answer. He will say, right? As far as I concerned, by seeing the previous paper, I got to know. He will say which merge patterns also. Just to do 2. If you are okay with 2, you are okay with the remaining things also. Normally, he will ask two-way merge pattern. So, can you help you now? These 3 files, you have to make it as single file. By using two-way merge pattern, means two things you will merge. Some people are asking, so what is the problem? Now you will see now. Let me merge now. Can you help me now? Optimal merge pattern input, n files will be given. Output, single file required. Right? After merging all these. I want finally single file. Now as of now I have n file. I want finally single file. What does it mean? You have to merge. When you say merge, they should be sorted. Of course, x contain 100 record, they all are sorted. Y contain 150 record, they all are sorted. Similarly, Z also. So 3 files are there. You want to make it as single file, right? Using two-way merge pattern, right? So some people are asking, sir, then what is the problem here? Now you will see. Input and output is clear. What problem you will get? You will see within a few minutes. Greedy technique, how it will solve the problem, we will see now. right? So I am thinking that almost problem is clear. Input is okay, output is okay. Now let's check here. So you have to make 3 files as single file, means you have to merge using two-way merge pattern. I am merging now. See this one, I am merging. So you know very well merging. See this one, X contain 100 records. See this one, X contain 100 records, Y contain 150 records. Merge them. Two-way merge pattern means two things you have to merge. Merge every one now. What is the meaning of merging? 100 people this side, 150 people this side. Compare both. Right, in this 100 records, first record, in this 150 record, first record, both compare. By comparing both the record, which is smaller, move there. Right, next one again, first one of both compare. Whichever smaller move. Can you help 100 people, 150 people, if you merge, can you help move how many? Everything should move. Moves how many? Everything should move. Can you help 100 people should come from this side, 150 people should come from this side. Based on which is smaller, that will come. So total how many moves? Number of moves are 250. But how many comparison? You know very well. How many? 100 plus 150 minus 1. That is the maximum comparison. Minimum comparisons are going to be. In these two people, which is smaller, that one. You know very well. Same merge algorithm. 100 people one side, 150 people one side. If you merge, total moves how many? Everything should move 250. Can you say total comparison how many? Comparison is two types. Minimum comparison, maximum. Maximum 100 plus 150 minus 1, because for the last one no comparison. Minimum, whichever is smaller, those many comparison. You know very well. Can you help Moves how many? 250. Let me write now. This is called as record moments. These are records. Record moments. In this problem, we are finding record moments only. Records are moving. Here 100 records, here 150 records. Totally 250 records are moving here. Please be careful. You done merging means 250 records are moved already. Next one, can you help Two files, you made it as single file. That's okay. One more file is there, Z. 70 records. Merge them again. What is the answer? 250 plus 70. What is the answer? 320. Check now. So 270 plus 50, which will goes to, right, 320. So I think 320 moves. See this one. I think, can you help in this problem? How many times you done the merging? 2 times. First time 250 moves. Second time 320 moves. Can you say total moves? 250 first time, 320 next time. Total is going to be 570. 570 moves required. Some people are thinking that only 320 moves. No. Because you done 2 times merging. First time merging required 250 moves. Second time merging required 320 moves. Totally 570 moves required. If you merge 3 files as single file using two-way merge pattern like this, I think 570 moves required. Please be careful. Some people are asking, sir, why are you merging like this? Why can't I merge some other way? See the some other way? See the some other way. X, Y you done. You may do like this one. See this one? X, Z I will do. X, Z. What is the X? What is the X? 100. What is the Z? 70. Move them. So what is the answer? 170. Here 170 moves already done. When you done merging, right, 170 moves are over. What is the missing one? Y. It is going to be 150, 150, 170. How much? 320. Right? Second time merging. I think second time merging both same. See this one. Here second time merging 320. Here also second time merging 320. But first time here 170, but it is a 250. If you add both of them, what is the answer? I think 490. Comparing the first one, this may be better. See this. See this one. How many times you done the merging in this diagram? 2 times. First time, second time. Right? Second time 320. Here also second time 320. Right? But first time here 170, but first time here 250. Because the first time here little more came, here more came. Here first time little less came, here less came. Right? Anyhow, comparing the first merging, I think second merging is better. Because less number of moves. Let's see one more way there. Let's see one more way. See the answer? What is the one more way? X, Y done. X, Z also done. I think Y, Z is left out. Let me check. Y, Z. What is the Y? 150. Can you say what is the Z? 70. Add them. What is the answer? 150 plus 70. What is the answer? 220. Right? With that X, how much? 100. It will become, what is the answer? 320. I think first merging how much? 220. Second merging everyone is 320. So if you add them, what is the answer? I think 540. I think 540. Right? Can you help me now? Merging 3 files. Merging 3 files. Right? Merging 3 files as single file using two-way merge pattern. 3 ways are there. Please check. Out of 3 selecting 2. 3C2 means 3 ways are there. 3 ways I done. right? In the first way, if you see, I think 570 record moves required. Second way, 490 moves required. Third way, 540 required. Can you say among all these merge pattern, which one is the best one? I think second one, because it is giving less number of record movements. See this one. This merge pattern is giving less moves. It is giving less moves. Less record movements or less moves, whatever it may be. Less record moves. Less record moves it is giving, so that is the reason this is called as optimal merge pattern. Optimal merge pattern. Merging 3 files 3 ways are there. First one is giving 570 record movements, second one required 490 only, third one required 540. So second one is giving less number of record movements, so it is optimal merge pattern. It is optimal merge pattern, right? Please be careful. Second one is optimal merge pattern. Now can you help me now to solve this problem? Am I done here, right? Any shortcut or manually I done every possible I covered. See this one, out of 3 selecting 2, 3C2, 3 ways are there, right? All the ways I completed. See, can you help in all the ways you completed? That's okay. Greedy technique means completing all the ways or shortcut. What is the shortcut here? Let me check. If you observe clearly, what is the shortcut here? Very simple. See this one, among all these 3, which is taken more? This one. Which is taken more? This one. Which is taken less? This one. Which is medium? This one. Now let's see the interesting answer. See this one. See the interesting answer. So among all these 3, right, this is taken very less, this is taken more, this is taken medium. What is the reason also I will explain. See this one. What is the reason also I will explain. Observe both the 3. See this one. Observe all the 3 diagrams. Observe all the 3 diagrams. Second merging 320. Observe all the 3 mergings, right? Second one is 320 there, here also. Even though second one is everywhere 320, but overall if you observe, this is given very less, this is given more. What is the reason? This is given very less. The reason is, right? Total merging, see this one. Total mergings in this diagram is 2 times. Second time is everyone is 320, but overall it is given less, indication that first merging is less here. See this one, first merging less. But here first merging more, here first merging is medium. If the first merging is less, then less answer will come, right? If the first merging is more answer will come, right? If the first merging is medium will come. What is the reason? Second one is same for all. Now can you help me now? Why second merging is given less number of mergings? Sorry, why second merge pattern is given less number of record movements? What will be the reason? I am repeating once again. Why second merge pattern is taken less number of record movements? What is the reason? So in every diagram, in every one, 2 times you are doing merging. In every merge pattern, 2 times you are doing merging. Second time merging, all 3 are taken 320, 320, 320. But first one, whichever less, that will be the answer. Some people are asking, sir, first one less, why? This is the answer. Why? If the first one is less, right? So second one is everywhere same, first one is less means less will come. Why second one is came less? Nothing there. Listen, this is the logic now. Second, by seeing the second one I got to know, this is the logic what you have to follow. What is that? Right? So initially whichever will give merge after merging moves are less, right? That will be the most probable answer. What is the reason? Initially less coming, over last round all will be same. Initially whoever is less, that will be the answer. Some people are asking, sir, how to get this kind of answer? Very simple, very simple. When you start merging, don't merge whatever you want, right? Take 2 minimums and merge. So can you help me now? Out of these 3, which one is the optimal merge pattern? Second one. Out of these 3, which one is the optimal merge pattern? Second one. I am okay with that. But how to get the second one? How to get second one directly? If you do manually like this one, right, you will get the answer, but it will take lot of time also. But how to get the optimal merge pattern directly? Because greedy is a shortcut. How to get the second one? Very simple. What the second merge pattern saying is, if you want to get the second one directly, what you have to do is, right, don't merge blindly 2 people. Don't merge blindly 2 people. Take 2 minimums and merge. That is the logic. Anyhow you are merging. See this one, 2 files anyhow you are merging. Don't take blindly 2 people and don't merge. Take 2 best people and merge. If you take 2 minimums and if you merge, less will come. Again take 2 minimums and merge. Next minimum will come. Every time if you take 2 minimum merge, 2 minimum merge, 2 minimum merge. What is the meaning? At the bottom level you will get the less like that. but last level all will be same, right? At the bottom level whoever is better, right? Overall he will be better because last level anyhow all will be same. So can you help me now? So to solve this problem, optimal merge pattern problem to solve, one way is do manually like that. It will take a lot of time. One more way, if you want answer directly, second one like that. If you want answer directly, what will you do? Take two minimums and merge. Take two minimums and merge and so on. Some people are asking, sir, first time only I should take two minimum and further also. Everywhere take two minimum. First time two minimum, less came. Again two minimum, next less, next less, next less. If you take only first time two minimum, you will get the minimum, but right, overall may not be minimum because second time you are taking whatever you want. Please be careful. If you want best answer finally, right, everywhere take two minimum, two minimum, two minimum, two minimum. Some students are asking me, sir, this problem is looking like Huffman coding. In Huffman coding also you are taking two minimum, two minimum. Exactly, Huffman coding this one same. In a Huffman coding also you will take two minimum, two minimum, two minimum, so that bottom of the tree contain minimum people, top of the tree contain maximum people. From root only you are giving code. Toppers will be there close to root, they will get the less code, right? So those people who are having the less frequency, they will be bottom of the tree. From the root you are giving the code, they may get the more code. You know very well. Huffman coding logic, this logic same. Applications may be different, right? Way of saying may be different, but both same, right? What this particular one saying? Take two people merge, take two people merge. That is called as merge pattern. So many merge patterns are there. Optimal merge patterns if you want, right? So take two people which are minimum, merge them. Next round again two people, right? Merge them, you will get the next minimum, next minimum, next minimum. All minimums will come at the bottom. At the end all will be, at the last level all will be same, because if someone is given bottom minimum, right? Overall becomes best. So try to remember, next problem onwards, don't do this entire story. What will you do? Do directly this one. Do directly this one. How to get this one? Take two minimum, and one more interesting answer. Huffman coding this one same, but in the Huffman coding, take two minimum, that's okay, right? But in those two minimum we will combining. Left should be smaller, right should be next smaller, but here not like that. Take two minimum, right? Left you keep anything, right you keep anything, because here there is no coding. In the case of Huffman coding, coding also there. If you keep whatever order you want, 0 becomes 1, 1 becomes 0. Here no coding, nothing. Take two minimum, left anything, right anything. Their coding purpose, you should be careful. Left is right first minimum, right is next minimum, but here not like that. Take two minimum, you keep right whatever you want any side. Some students are asking, sir, here you are taking two minimum, that's okay. But am I taking two minimums here one time or many time? Many time. If you want minimum many times, go for mini heap. Try to remember this one. Mini heap is meant for that. If you want always minimum, best data structure, mini heap. If you want always maximum, best data structure, then go to maxi. Right? Please be careful. So try from next problem onwards, directly take two minimum using mini heap. So I'm thinking that you are absolutely fine. Can you help to this problem? See, what is the application name? Application name, optimal merge pattern. What is the meaning? You have to make n files as, right, single file. Means you have to merge. For that, many merge patterns possible. So optimal merge pattern is second one. How you got? By taking two minimum, I got the answer. So next problem onwards, do directly like second one only. Don't do all the possibilities. All the possibilities also you can do, right? But it will take a lot of time. It is a wastage of time also. Can you help finally to this problem, right? Minimum number of record movements, how many? 490. What is the way of doing, right? Like this. Let's go to the second problem, you may get more clarity. See this problem also, example 2. One example is over, one more example I am doing, please be careful. Please be careful. Let's write n is equal to 7. What is the meaning? 7 files are there, names, A, like that, right? 7 files are there. So I am thinking that everything is fine now, right? Let's start. What is the answer? What is the answer? Always you have to take two minimum. Can you help me? How will you take? So take all these people. This one, I think this one, n is equal to 7 means what? 7 files there. These are the files. Only files take into min heap. This indicates 7 files there. Those are these. Where every file contains some records. Right? That's okay. So for all these n people, create min heap. For all these n people, create min heap. What is the answer? Order of n time using build heap method. Using build heap method for all n people, right? Create min heap. Order of n time. Right, fine. Now let's start now. You want 2 minimum, delete 2 times. Delete 2 times, D1 and D2. Delete 2 times. First time delete, who will come? E. 3. Second time delete. Second time delete. After 3, what is the next minimum? After 3, what is the next minimum? D, which is 8. So 2 times delete, D1 and D2 came. First time delete, 3 came. Second time delete, 8 came. I am thinking you are okay now. As of now, it is fine. Now let me ask you one small. What is the answer? E, 3. Right? D, 8. 2 minimums, right? You take any order. There is no objection at all. You take any order. But one thing, 2 minimums you take. 3 and 8 I took, which are minimum. Right? Add them. How much? 3 and 8. What is the answer? 11. Add them. I added. Let me delete because of 2 deleted. 3 over, 8 also over. Right? 2 deletions from the min heap. What is the answer? 2 login. So what is the result came? 11. You have to insert the 11 inside. Total becomes 3 login. Exactly like Huffman coding only. Both same. The only thing in the Huffman coding, left smaller, right greater. But here anything. 2 smaller you take, right? Add them, result keep inside. Right? Once again similar way. Delete 2 times, 2 minimum. D1, D2. Can you help me? If you delete now, as of now, who will come out? I think B will come, which is 9. What is the next? G will come, which is 10. Right? These 2 people. So let me write now. 9, 10. I think see there is no relation with this. It is 11. Right? 9, 10. So 11 went here. If at all he is the next minimum, he will come. Because if he is not next minimum, he didn't came, remaining people came. I think 9, 10. You write any order, no objection at all. What is the answer? B, 9. G, 10. Add them. How much? 90. Right? 90. So like this. So let me delete this also. 9 also over. 10 also completed. It is the 3 login. So I am thinking that until now everything is fine. It is the correct time. Right? Now next one. Once again. It is the 3 login. So delete 2 times. D1 and D2. 2 times delete. Can you help me? If you delete first time, who will come? Available people, best people, please check. Who is that? 11 will come. It is the first minimum. Next. I think what is the answer? 13. C, 13. Right? 11, 13. 11, 13. Any order you can write. 11 is there. C, 13. Which will goes to what is the answer? 24. 24. It is 3 login. Let me delete now. 11 I have to delete and 13 also I have to delete. That's okay. Next. Next, can you help me once again now? Delete 2 times. 2 minimums. D1, D2. Can you say who are those available people, best people? First of all, who are available? 20 available, 24 available, 19 available, 15 available. Best one. Best one. I think 15, that is the F. Next. 19. Right, these are the 2 minimums. I think 15 and 19. 19 is there, 15. Any side you can keep. Right, F which is 15. Right, F which is 15. I think everyone fine. So add them. Can you help me now? 19 and 15. How much? 34. Check once. Right, 34. Let me keep 34 inside. Yes, I kept. Right. So let me delete now. Who are the things? 15 delete. 19 also delete. 34. Okay. It is also 3 login. Can you help me now? 3 login, 3 login. How many times? Totally 7 people. 6 times you should do. Because every time one only going. How many times you done until now? I think 4 times. Right. I think 2 more times is there. Let's do that also. Delete 2 times. Delete 2 times. Can you help me now? If I delete now, who will come out? I think, see, first of all, who are available here? Who are available? I think 20 available, 24 available, 34 available. 2 minimums. What is the answer? A 20 will come. Next, 24 also will come. 2 people. 20, 24. 20, 24. I think 24 here. A 20. Add them. How much it is? I think 44. 44. Let me check. 20 is gone. 24 also gone. Now left out people. 34, 44. Let me delete. 34, 44. These 2 are next minimum. I think these 2. Add them. 34, 44. What is the answer? 78. Right? Inside 78 inside. 78 will go inside. Then delete. Let me delete. 34 is out. 44 also out. 78 came. It is 3 login. Right? Now can you help me once more? Whatever answer you got, let me check. What is the first step? Because of you want always 2 minimum, 2 minimum, 2 minimum, create min heap using build heap. How much time? N. Time complexity of optimal merge pattern is equal to, what is the answer? Creating min heap is n minus 1 time 3 log n. So which will goes to n plus n log n, which will goes to n log n, which will goes to n log n. N plus n log n, so n log n. So now let's see this one. I think this is the tree which is available. Now some people are asking, sir, what is the name of this tree? Let me write, you know very well, two-way. This one, two-way. What is the name of this one? Two-way merge tree. Two-way merge tree. Previous one is two-way Huffman encoded tree, right? This is going to be two-way merge tree. Both will be same. Here, the only difference is what is left, what is right. I don't bother. Two minimums I want. Every time take two minimum, two minimum. If anyone do this problem wrong, what is the mistake? Initially they took two minimum. Afterward, they are not taking two minimum. They are taking one minimum only. No, every time two minimum. So as a human, you may do small mistake and all. Do like that, right? Min heap tree don't give anything wrong. Always take two minimum. Like whatever I done, do that. When you are really confident, you may not do like that also. Directly you can do. It is up to you. Two-way merge pattern, right? Sorry, what is the name of this one? Two-way merge tree. Some people are asking, two-way merge tree I created, it's okay. Two-way merge tree I created, it's okay. But minimum number of record moves, how many? Let's see this one. See this one. Minimum number of record movements. Minimum number of record movements is equal to, see the answer, minimum number of record movements is equal to, see this one, sum of internal nodes, please be careful. Minimum number of record movements is equal to sum of internal node. Can you help me now? In this diagram, who are the internal node? In this problem, in this diagram, who are the internal node? Everyone now. What is the answer? After merging, you got this. This is the internal node. After merging, you got this one. This is the internal node. So all internal nodes came after merging. Please be careful. It is the internal node merging. It is also internal node merging. It is also internal node merging. So every internal node is came after merging only. Means these are moves. Can you say all internal nodes? What is the answer? Right? 11 plus 24 plus 44 plus next 78 plus 34 plus, right, 19. Add them, you will get the final answer. Something like 210. Please verify properly. Right? 11 plus 24, which will goes to 35. 35 plus 44, which will goes to 89. 34 plus 44, which will goes to, I am saying this is 35. This is going to be 44, which will go to 79. I already done. Plus 78. Right? This is going to be 53. Right? What is the reason? 20 plus 33, which will goes to 53. Right? If we add all of them, 210. So minimum number of record movements is equal to 210. Some people are asking, minimum number of record movements are 210, it's okay. Right, see this one. Sum of internal nodes. All internal nodes you take. What are the internal nodes? 11, 24, 44, 78, 34, 19. All the internal nodes you take. You add them, you got 210. Right? So if you can add your own way, total sum becomes 210. So minimum number of record movements are total for this problem 210. If anyone do other than this approach, right, you will get either 210 or you may get more. Please be careful. You cannot get less than this because it is the optimal answer. Minimum number of record movements you will get directly by following this story. What is that? Always take 2 minimum, 2 minimum, 2 minimum. Right? You will get this. If anyone follow other than this approach, either you may get 210, right? You may get more. Please be careful. You don't get less. There is no chance of less. If you are lucky, same thing will come. If you are unlucky, you may get more. Right? Please be careful. Just follow this approach. This one Huffman coding same. Right? Time complexity also same. See, time complexity also same thing. This is for creating mini heap. Right? This is right every time 2 deletions, 1 insertion. 3 log n like that. N minus 1 time n log n. Which data structure you are using? Min heap. Why you are using min heap? Always I want minimums. What is the name of this tree? Two-way merge tree. What you are doing? Always taking two things and merging. So what is the final answer? Sum of all internal nodes. Why sum of internal node? Internal node came after merging, means they are moves. Right? All internal nodes you add, you will get the moves. Because the best approach you followed, this is going to be minimum number of moves. Right? So you add all of them, you will get 210. I added. Right? I got 210. This is 79. This is 78. 34 plus 19, which will goes to 53. So 79 plus 78 plus 53, add them, you will get 210. So what is the answer? 8 plus 3, 11. 11 plus 9, 22 here. Right? I think 3 7s 21. So 210. Time complexity n log n. Please be careful. This is the name of this one is going to be optimal merge pattern, which is like Huffman coding.